We are back. More cast today. G. Okay. So last time we did the functions, right? So we have the ability to define functions in kast now. Just run REPL, right? We have something like function f is x into x, right? The identity function. If I call it with hello, I will get hello back. As a simple example of this, we have mutual recursion and other things. So now that we have the functions, we can do the other things that required functions, specifically macros and templates, because those are just special cased functions, kind of. So let's start with macros, right? If I go to the std syntax, I have a couple lines that are commented here in the end. For example, we had the, postfix++ is, do I have the postfix++? Yeah, I do have postfix++. All right. That's not the important one, right? I think the important one is, is the pipe. This pipe, we want to pipe an argument into a function, or argument into a function from the left or from the right. We have these two pipe operators, right? So this is supposed to be a library thing. You can see that these things defining a function, for example, is a built-in macro, but this one is going to be a user-defined macro. Let's call this specifically pipe right and pipe left, maybe. Right, and yeah. Let's run the REPL. If I say something like hello, and I want to pipe this into the native function print, right? Then it will say that it's not yet implemented in the compiler 123. Compiler 123. This specifically is about if a macro is not a built-in macro, right? So we are trying here to see if this is a built-in macro. Then we are doing the built-in things, which are implemented here in the Rust code. But if it's not a built-in, then it's supposed to be something implemented in the user kast code, right? So what we need to do is we need to self-interpreter. We need to get self. Have self. Hold on, where am I? I'm inside kast. I don't have self. I have kast. Kast interpreter get the macro name. The definition name, right? This is the this is async too, right? Yeah. So I wait this here. So I say something like if let some macro is that, then we do one thing. Otherwise, we will say that I fail. I guess let's have the name here in the variable, right? Definition name. Let's stir. I will say something like name was not found. Right? I guess that's it. And if the macro is actually found, then I need to invoke it, right? Then I need to invoke it. Let's see. If I try to run this right now, though, once again, let's just run echo hello into native print, right? That's what I want. And we go this into REPL, right? So while compiling pipe right, the pipe right was not found, right? So we need to have the definition of the pipe right. Right now, I'm not including the standard library. I'm just like parsing the syntax from the std syntax. Wait, which actually means that maybe what I need to do first before implementing the macros is like importing files properly, because I'm kind of like cheating by parsing the standard syntax. It's supposed to be like a normal module. Hello print. I mean, or we can just have this inlined here for now, right? Let's see what we want. We want to have a pipe right. Pipe right is going to be a macro function which takes arguments. I guess it's argument and function, and we return function called with arguments, right? So what do we have here? We have so this over here is the function definition. The argument to the function is a tuple with argument and f fields. And then we use the quote operator to return the new AST here. Basically, this, if we want to make this completely full, then argument not sure which, like this is AST basically, but this is a field. We have arg because we have a field named arg and we bind it to a binding named arg. In order to have this like without a repetition, we need another macro basically, which is defined in the other place. Dagger, hello. Let's have this for now. I mean, the fact that this arg is AST is going to be inferred anyway. But this is basically a so the macro is a function which takes as its argument like some ASTs. In this case, the f is an AST of the function that I'm trying to call, and args is the argument, the AST of the arguments that I'm trying to call, and it returns a new AST using the quote stuff. So whenever we see the syntax, the pipe right, which corresponds to this macro, is just going to call this macro with hello being args and native print being the function, and then it's just going to call it basically, right? There you go. So now we need to create the built-in function macro. Sure. Let's try that. So here's the function definition, but we want to have macro for defining macros, right? Macro. So so macro std syntax. Let's see. Macro definition, right? This just it wants to have the definition, which is just a function definition, just a normal function. And we just mark this function to be a macro, basically. That's all we do, really. That's all we really do. So definition is values as ref into single named definition ref error with macro received incorrect arguments. Right, so we have the definition. Also, macro only works for expressions. It cannot be in pattern. We will return okay, compiled expression. So this will be a macro expression, right? Did I have a macro expression before? Just converts a function into a macro. I mean, makes sense, sure. Data is span, initialize this, that. So we want to have the definition. Definition is going to be compiled. I guess the macro is going to be boxed. We are going to compile the definition. Right? Dev Ninja, hello. So definition is going to be the expression, basically, right? So yeah, let's see. We'll have another type of expression, which is a macro expression, which takes the definition of the macro and like constructs the actual macro. Right, collect bindings, expression, macro does not make stuff. Show short expression macro. Macro expression macro expression macro. Okay, when I initialize the macro expression, this is where we specify the where we initialize the type inference stuff. So what's the type? Sorry. What's the type of the macro, right? What's the type? The type is just... Thank you. The type is just a type macro, right? Right? So we need to like make sure that the definition is a function which all it can take is like ASTs, basically. Did I do this inference stuff before? I'm not sure even if I did. Let's take a look. Kast all the camel version. Over here, the initialization, if I have a macro somewhere, I will have a macro, right? Wait, do I even have a macro? I think I don't even have a macro. How did it work then? Let's take a look at what the value was. So one of the types of values is a macro. We have functions, we have templates, and we have a macro, right? So in order to construct a macro, we are using the built-in macro macro. There it is. So I'm like literally taking function f and just converting it into a macro f. Oh wait, does it mean that I need to like know the function at compile time for the macros? Yeah, because macros are supposed to work at compile time anyway, right? So that means that whenever I have a macro, it's a macro is a function. It's not even like, yeah, okay. I see what it is. So I don't have the macro expression then. I only have the macro. Yeah, sure. Let's undo. Delete this. Delete this. Delete that. Delete that. Delete this. Delete that. No variant macro. So like instead of constructing the macro expression, this thing is going to, instead of compiling the definition, it's going to evaluate the definition. Right? And I can give it some expected type here too. We can for now just have none. Maybe we have to do expect some type here so that the type inference will work better. But I think the type inference is going to work fine because I'm going to use the quote macro, the quote stuff anyway. So we so instead we compile it to a constant, right? We compile it to a constant. And hello, Nigel. So this is a built-in function. Okay, okay, so the way this worked is that if I have a syntax corresponding to a function and not to a macro, then std syntax, let's take a look here. Macro. Yeah, you see, this is a built-in function, not a built-in macro. Which all it does is just converts the function into a macro. I don't know if that's correct actually here. You added the instant global search picker for Helix in your own fork. Starts the picker for a global search without the need to enter a search string beforehand. Nice, I guess, if this works. Didn't someone say that it's already in the master though? Or were they referring to something else? I'm not sure. Built-in macro. Maybe I can still have it as a thing. I don't know. No, I'm not sure. I'm not sure. I'm not sure. The problem with this being a function, is that this function would be not well typed, right? Because the argument to the macro is function that can have like different arguments. Let's keep it a macro. Anyway, so yeah, when we see a macro in code, we are going to evaluate the definition in compile time, basically, right? And I'm going to return as a result an expression which is a constant expression where value is the macro, right? Value is value macro, right? Value macro, which is like this definition, right? Which means that the definition must be specifically a function, right? So let's go to the definition first. So here's my values, right? Values can be, these are all the values that we have for now. So we will have the macro. Macro is same as a normal function, technically, just a little bit special. Let's see now. On function macro. Display macro. We will write macro. The type of a macro. The type of a macro is going to be the macro type. Or how did I work with the macro types before? Let's see. Was it even typed? I'm not sure if it was. Let's see. Template is the same as function. No, this is the integer representation. What about the types? The type is here's a function, here's a macro. Yeah, it does have the function type. Okay, I mean, sure. Type macro. So it's kind of like the same here then, right? Box new function type clone. Yeah, sure. Let's do that. So we have the type, which is going to be a macro type of the function type. Function macro. Make same. Macro. A display type macro type. So in order to display the macro type, we say first macro, and then we display the type of it. Macro type, I guess, something like this. Okay, and then in order to expect function, we have expect string, right? Of expect string. Let's have a public function expect function, which should result into function and expect error. Self function f else error expect error value self expected type function type. I mean, we expect function of any type here, technically, right? So we're just going to say that the argument is just a type inference variable. I call it infer. Maybe I should rename this to a variable. We'll see. I sense hello. So we expect this to be a function. We construct the macro and we do things, right? Let's try again. We're going to miss other parts now, right? We have the macro tuple, so we don't have tuples yet either, right? Because this macro expects 2 arguments. In order to have 2 arguments, we need to have a tuple. So let's make tuples now. Let's see, macro tuple. Macro tuple. Macro tuple. STD syntax macro tuple. So this is just like having A and B. Right? Yeah. Okay. Sure. C. Let A. Let A and B to be values as ref into named opt. Names are A and optional name is B. Like that. A tuple can be a pattern technically. Yeah, and in this case it is a pattern because I'm declaring the arguments of the function. So this is a pattern tuple, not a value tuple. Okay. All right, let's see here. So we're going to say, okay, self compile into compile type. A, right? Let A be that. Let B is match B, sum B self, sum self compile into time B await question mark, none and then none. Like this. Compile into. I'm using this in other places somewhere, right? Oh, just over here for the type description. Yeah, okay. So I guess I need to like match the compile time here. If we are trying to compile a pattern, let's try with expression. Let's try with expression, or actually let's try with a pattern, because that's what I want to have in the current macro, right? If I want a tuple pattern, then we will want to have compiled pattern. So we will have a pattern for tuple, right? Also, like, also, hold on. Actually, what I need to do here, is I need to see if this is like a tuple with more than just two fields, kind of, right? I don't know. Let's keep it like that for now. I'll fix that later. For now, we literally want to have a tuple with two fields. I'll fix that later. Tuple. So I need to have a tuple pattern, right? Which specifies the unnamed and named fields. So this means that I need to compile this. No. I'll fix this later. That and other lies software devs tell themselves. I'll write a test and it means that everything will work is another lie that some developers tell themselves. Let's see. So like I need to investigate the ASTs here a little bit further because yes, because we need to. You only say that since you never did TDD apparently. No, we did test-driven stuff. I guess I guess I never tried like to have a billion tests, so that all I did was test. Like, yeah, yeah. Test-driven development is when all you do is tests, right? Is that it? Yeah, I never did that. Um. Boom, boom, boom. You start with tests. What then? After you have the tests, you have first implementations, even test first, implementation second. What happens when you realize that the test was wrong? Do you write tests for tests? What happens when you're I guess you never just go and implement something that is not already covered by a test. So you start with a failing application because it's not passing the tests. Test won't be wrong, trust. And you adjust tests and fix implementation. Okay, how to do a tuple? How to do a tuple? I need to like collect all the fields in one go here, right? I think so. I think so. Rust don't really need tests. Yeah, there you go. There you go, Devninja. You only do test-driven development because you never tried Rust. That's the actual issue here. You need to start writing Rust, and you will realize that test-driven development is actually the wrong way. You want to have type-driven development, not test-driven development. Um. 60 hours TLD. Are you participating? 2 days and 11 hours. You never made a game in your life? Well, you can change that by participating in the Ludum there. It's not that hard. You know Rust, you can try to do something with very easily, right? Unless you don't want to, that's fine. Game jams are not for everyone, I guess. They're just fun. Let's see. Collect fields. Collect fields from A, right? And then B itself must be a single field, right? Let A is collect fields A. Let B is B map collect fields. Where, let's see, what is a collect fields anyway? Collect fields is a function that would get the AST and give me a tuple of ASTs, right? So a tuple is something that gives me named, unnamed things, everything, right? Yeah. So we see here, we match AST, right? If it is a syntax definition, let's have is this Z? No, this is Vim. Hello there. Should this be able to fail? What happens if I have a syntax definition? No, I mean, I mean, in this case, I mean, the only thing that I care about actually is the complex definition. Specifically the one where definition name is equal. So we're going to hard code this name here, I guess. I'm not sure how to do it without hard coding. Built-in macro tuple, right? Okay, this can fail because the tuple can have the incorrect macros. Let's have IRE result. So we'll do a question mark here, and we'll do this transpose question mark, right? B is an option compiled. Yes, it's not compiled. I'm not compiling anything yet. We just do this. There. Yeah, yep. Okay. Let's see. Function, tuple, arguments. Values, tuple AST is 2 ASTs. Which one of them is optional? And we do this. This will be a result. So we don't do a question mark here, right? Well, I mean, we do have a question mark. We just return okay, A and B. Right, there you go. So first we say that let A and B be tuple args of my original values, my original arguments. Why do I call these values? These are the arguments. Whatever. And over here, since this is a tuple, which is a nested tuple, maybe I should have like some sort of another helper. You know what I'm trying to do? Look at my beautiful Ludum there, wallpaper, by the way. So what I'm trying to do is if I have something like ABC, right? Technically, the syntax that we have only specifies the way to combine two values, or like a tuple with a trailing comma, right? So in order to parse a tuple, which is like ABC and then like also D:E, which is like a named field in this tuple, in this case we need to first like get the list here, basically, right? So we want to like fold the recursive tree structure here, which would look something like this: tuple where we have like tuple where we have tuple. We start with a tuple of A and B, right? And then we add the C to, and then we add the D to this one, right? So we have a tree structure like this when we see A, B, C, D in code. So we need to like be able to fold this into the either allow only unnamed / named tuple, not a mix of both. Wait, no, that's not the problem. The problem is that like it's in this tree structure instead of being just a normal list. So I want to be able to have the list here. That's it. That's like maybe I just want to have a helper that can do this for other things than tuples later, you know, like collect list or something, you know, function collect list, which needs to have the so I will need to like have these A and B to be like customizable, and also the name of the macro is customizable, I guess, right? So let's see, macro name is stir. How about we do this into a struct list collector macro name stir. We have A stir, we have B stir, and we will have impl list collector. So these are going to be the methods on it instead. Collect, so we're going to collect the AST, right? Which is going to give me not a tuple. I'm going to literally collect a list, so like a vec first. Specifically the tuples are going to use this like to process it further, right? So we collect the AST into like the list of ASTs basically. So if the definition name is equal to self macro name, only then we say this, right? A and B is that. Oh, but the tuple R is like needs to be there. It's like I need to have the original AST here, which I don't have access to anymore because I have already like taken the tuple out of it. Maybe I need to give my macros the original AST, not only the values. Yeah, sure. How about that? I'll change that. AST. AST is AST. Okay. So this is not A, this is self A, and this is self B. So we're going to have a list collector where macro name is basically AST macro name. Let macro name be match AST. It must be the complex one here, otherwise it's pretty much unreachable. If it's a complex definition, values, data. Yeah, like I don't even need the values here, right? That's all we need. Kind of. Say that this is definition name Esther. List collector. Collect the AST at fields. So this is like the list of fields basically. We're going to collect this where this A is A and B is B. Go. So these are the fields, and then we are going to do other things with the fields. Just make sure that my tuples, that my macros can be like this. So macro is just a way to expand a specific AST. So it basically means that the AST has been already checked to be corresponding to this macro, I guess, right? Yeah. Let's see. So this means that the built-in macro is something that does not have the values in span, instead just has the AST directly. sure. Let's go to the built-in macro here. Type built-in macro. Built-in macro is something that just takes the AST like that. Okay, this is a to-do. All right. So now we have all of these different things that needs to be changed. Right? So we will have AST. Let's just have a way to like say that values and span is get complex AST. Get complex AST, sure. Let's have a function like this somewhere. Somewhere in this file, in some random place in the end, sure. Function get complex AST just gives me a tuple of AST and reference to a tuple of AST and the span. So we're going to match it must be always a complex one here, otherwise it's unreachable. Definition. So with the definition is what we ignore. We just have the values and data. Data is the span in this case. So we just return values and span like that. Span needs to be cloned, I guess. Sure. Okay, and then we do the same in other places. Type ascribe. AST is AST. Let values span is get complex AST. Just start with that basically. AST. Let values span is get complex AST. AST. Values span is get complex AST. Which one is wrong? This one. Definition. Should have recorded a macro by this point. Let's start doing this. Record a macro. Do this. AST. Let values span is complex AST. Okay. Like that. Expected 3 arguments, found 4. So this also is going to be like AST. I recorded the macro just in time, where there was only 1 left. Amazing. Apparently. Over here we don't do this, we just give the AST directly, right? Which means that the values, we just like ignore them here, kind of. A little bit of a copy pasta. Not sure how can I get rid of that one. We'll see, maybe at some point. Macro let. So as I'm calling the other thing, we just do that. The values we just ignore. Here we just want the span. Lifetime might not live long enough. Lifetime might not live long enough. Closure was supposed to return the data with lifetime 2, but it's returning the data with lifetime 1. Built-in macro. Built-in macro. Oh, because because over here I forgot to type the lifetime. Wait, why is there 4AB? Was this supposed to be B? Why do I have 2 lifetimes here? I think this second lifetime is not necessary. There you go. Okay, not yet implemented. 460. 460 over here. So this is it, right? I'm trying to collect the things into a list, right? We know that what is A and B. I know that this is like the so yeah, I'm going to collect recursively the A into the list. You know, let mute result is this, and then I'm going to just push the B, result dot push B, and then we return the result here. That is it. Use the question mark to extract this value, yeah, because this can potentially fail, right? And then we return OK result. Yeah. Have OK in the very end. So we don't do it recursively on B because this is like a left associative thing. So the yeah. That's I don't know. Would I ever need to collect the thing where the tree is like going to the right? I don't know. I will change that if I need to. B is also optional technically, right? So B is also technically just optional. So we only do this if it exists. So if let sum B is B, only then we push it there and then we return the result. Now it says that the lifetime might not live long enough. Yeah, because I mean technically this lifetime is only tied to the AST. Makes sense. Makes sense. Tuple args, I don't need that anymore. Data, I don't need that anymore. Right? So yeah, and then if it's not a complex, this means that it would be like a terminal node. So we would just return a back of this single AST basically, because it can like it's not the thing that we expect. Okay, nice. So we are going to collect all the fields into a simple list here, right? Do a question mark. Now that I have all the fields, these fields also might potentially like be named or unnamed. Right. So let's see. We're going to have something. Let mut unnamed is a new vec, right? Let mut Hold on. Let's have a named field macro, named field definition name is what? What is this? It's a built-in macro. Std syntax. Colon. It's called field. That's what we call it. So built-in macro field is the named field. So we say that fields find, no, fields like we want to iterate over the fields, right? For field in fields, we say that if field is complex named field name, maybe let's have this thing, which is the same as that. I guess I can just match. Whatever, we just match field. Match field if it is a complex definition where definition name is named field name, then it means that the named fields, right? Then it means that the named fields, I mean, we're just going to construct the tuple here. That tuple is a tuple. We start with the empty one. We are going to construct this here. If it's a named stuff, then we are going to say that let so field requires a name, name and value is values as ref to named name value app error with field wrong args, something like that. So we have the name and the value, right? And we say that tuple add named field where name is name, right? Which means that name must be specifically this means that we must have a name to be an identifier, right? Name expect identifier. Let's go to the AST. Here's this thing. I mean, we want, we want this to be specifically an identifier, right? Unless we want to have like strings as fields. Do I want to have strings as fields? That would be like a JSON then. Or do I maybe want to allow any expressions there? I'm not sure. Let's for now have a function expect identifier self let's say as identifier, option identifier. But we don't have identifier as a specific struct, right? Because the token might be this, right? Let's have as identifier. So this will like just give me the name of the identifier, I guess. Then let's do this. Self. So it must be like a simple token where token is an identifier, and we only care about the name here. And then we return name, name. All the other cases we return none. As identifier, okay, or okay, or else format, okay, or else IRE name is not an identifier, maybe something like this. And then we want this to be converted into a string like that. Okay, nice. The data, we don't really care about that, I guess. So yeah, this is a named field, and then there's going to be like everything else is going to be the unnamed field, I guess. Right? So we say over here, tuple add unnamed field. Okay, and this is me collecting the tuple in the form. So this is specifically going to be a tuple of where every value is an AST, right? But since this is a pattern, I need to basically every field in a pattern must be another pattern, because we are pattern matching every field against the same thing, right? So we need to have tuple as tuple map, which means that, oh, do I have map? Yeah, I do have map. So we map every single like field into I wonder how can we do this. So like here's the problem. Technically, all I want to write here is I want to map every single field to self compile into that field, right? So we apply a function to every field. The problem is that this function is async and also is returning an error. But I cannot do a question mark or an await from inside this closure, right? So that's the problem with Rust. How do I write this instead then? Because I am not async here, I can convert this into like like I can like over here I'm getting these values, right? So I like the easiest way to do this actually is to do this in line when I'm constructing the values here, when I'm inserting the fields. Instead of inserting the field directly here, I will just say compile into this value await question mark, right? But like it's kind of annoying. It's kind of annoying, but okay. Sure, let's do that. So now it's not a tuple of ASTs. It's directly a tuple of compiled stuff. Depending on whether I'm trying to compile an expression or a pattern. We have compiled these things recursively, okay? So now we have a pattern. And we need to have a tuple pattern. Pattern tuple with the tuple inside, right? There you go. There you go. So we need to have a new type of a pattern, which is a tuple, which has inside. Let's have data. Yes, tuple. Let's have, I don't know. I guess we just say tuple here. Tuple is tuple of patterns. This is a recursive thing. Right, pattern tuple, and data is span. Then I would need to initialize this pattern too for the type inference. You're gonna compile my stuff in a second. Hello, Jerem. Are you going to do this on your work machine, since you are in chat with your work account? So over here, I'm going to map the tuple into field dot, this is compiled, field into pattern. I don't know, expect pattern rough. Tuple is tuple map. There you go. And where is the span coming from? The span is coming from the original AST. So AST data. Right. Okay, so compiled function into expect pattern self. Let's have option pattern. Right. No, if it's an option or result, whatever. Match self. If it's a pattern p, then I return some p. Otherwise, return none. We'll have the same method for the expecting expression, which will return us the expression. If it's an expression, e, when I return some e. Otherwise, it will return nothing, like that. None. Okay, let's see. Here's the pattern matching, actual pattern matching. No, hold on. Before pattern matching, we need to also have the values, which are tuples, which is not done yet too. Pattern matching can wait. Let's do some simple stuff over here. Self tuple data. Self tuple data. I can probably like write a derive macro to getting this. Getting this getter. Collect bindings. Or I could have like a pattern with like split into two separate things. Instead of having this the same field in every single variant. Whatever. Let's have this for now. Collect bindings. If it is a tuple, then I'm going to tuple fields, tuple map, tuple tuple values for field and tuple values, consumer, no, not consumer, field, collect bindings using the consumer, because every field is another pattern here, right? So we need to go to the tuple and we need to have the thing function values, which is going to give me impl iterator where item is t, I guess. So with a self unnamed iter, and then we chain that with self-named, chain that with self-named order, iterate map, name self-named name, the reference, right? Is that going to work? Looks like this compiles. Let's go next. When I initialize the pattern, so we need to have like a tuple values and tuple types too, right? This will be a pattern tuple. Its tuple data is pattern data span. So the type here would be the tuple type, right? So we have the tuple, this one. We do as ref, and then we do map field data type clone. So this would be like as a result a tuple of types. We will have type tuple like this, right? Okay, let's go to the type. We need to have tuple, which is a tuple of types inside, right? Okay, what is this? Equality. We would need to like zip around this thing too. Self tuple A and self tuple B. I mean, this is partial equality. I can implement equality for tuples directly, right? So we say A is equal to B, I guess, directly. If it's a tuple and something else, then we return false. Wait, I already implemented this equality for tuples, do I? I don't remember implementing that. Make same. And type tuple. Type tuple. A type tuple B. So in this case, I need to zip two tuples together, right? And then I'm going to like map the fields A, B. And map, and like, I want to map using a failable function. All right. Okay. Mapping using like a failable function is annoying. How would I do that? Instead, I guess we're going to like construct the tuple from scratch then, because map doesn't really work. That mut result is tuple empty, right? So then I will just go like for A and B. For name and AB in A zip B. Me watching you zip tuples and compile hearts. Oh, Pigorli is here. What's this new icon that you have, Pigorli? September 2024. I see. You've been thinking about adding named anonymous structs similar to tuples? That's literally what I have. I have a combination of anonymous, named structs and unnamed structs. I can have both at the same in the same structure basically. I can have both unnamed and named fields in the same anonymous thing, which I just call tuple. I'm not sure if there is like a better name for it than the tuple, because tuples usually is used for just unnamed things. But yeah. It lets me like model the named and unnamed arguments at the same time using like a dedicated type. Looks like the Kuvi art, this icon for the September. Looks nice indeed. Wait, do I have a zip? Oh, I already implemented zip. Look at this. I thought about this before. So what I want here is that I want to like convert this into an iterator then, right? Would return result. Mismatch types wait, so into iterator. Wait, I thought this would not compile. I did not implement the into iterator, did I? Tuple. Into iter. No, I don't have the into iter. How does this work even? This should not compile. Mismatch struct. Expected tuple of these, found tuple of those. This is an iterator with items of type tuple. Wait, what? Ten stream streak, nice. Hooligan. Me and Pigorli enjoying watching a talented coder with magic. I wanted to implement one thing, but in order to implement that one thing, I need to implement that other thing, and in order to implement that other thing, I need to like implement this thing. So we're going to get back to like the actual thing that I wanted to implement, which is like macros. Once I have this done. Right now I just need to have tuples in the language because I didn't add that before. Why do you say mismatch structs? Like, what is this into iterator? Like, because when I zip, I get a tuple. Oh, because zipping. Oh, I see. Because I have a into iterator is implemented for results. This is stupid. Why would a result implement in iterator? I mean, I understand the options, but this I'm not sure about. So I want to do a question mark here, and then we do into iterator. Zip. So now we want to, let's see here. We want to implement into iterator for tuple t for all the types t, right? The item is going to be a tuple where the field is a string, which is like the name. Wait, this is the name of the field, right? Which is an option string, because it's either named or unnamed field, and the value itself is t. There you go. Into iterator is a tuple into iter. Wait, and I cannot have like an opaque type here, right? Which is not implemented in Rust yet either. Okay, so we need to actually construct the iterator. Tuple into iter t. Tuple into iter t. I mean, I can have a boxed iterator, you know? Box din iterator. Item is option string and t. Like, I don't really care about this much. I think it's easier to write it this way. Box new Okay, let's see. So we are going to say what? I'm going to say going to make this mutable, right? No, I think I will have to, unfortunately. Product tuple into either t. Tuple is tuple t is going to be public. Tuple into either self. I guess I just have the tuple t here, like that. Is not an iterator, so now I need to implement iterator for tuple into iter t. The item is option string and t. Next, so I'm going to say that if self unnamed people. Just have this. I will call this reversed specifically because I will want to like I want to, because I'm storing these in vex, so it would be easier if I just reverse this vex maybe once in the beginning. Or what? Actually, you know what? How about we just construct the iterators immediately, like here. We will say that unnamed is the vac t as into iterator into iter, something like that. But I want it to be yeah, sure. Yeah, we just do this, and then names is back string as into iterator into iter. It is Cyprian. Hello there. And then named fields themselves are a hash map. Was it a hash map? It is a binary tree map. I can make this a hash map. It doesn't really matter what I use here, right? Because I have the named order anyway. Just have default here. Inbound hash map T. Oh. Is not satisfied. Oh, because hash map is not hashable. Of course. No, we want this to be a B-tree map. Okay, B-tree map. String T. There we go. So if let some unnamed field is self unnamed dot next, then we return some unnamed, right? Otherwise, it means that the unnamed fields have already are already not there, right? So we say that let name, the next name is self names next question mark, right? And we say return some self named remove using that name unwrap, something like this. The type construction contains t. Yeah. Okay, so like over here, I guess this is the value, right? That value be this, but we want to value. We want to have the name. So in this case, the name is none, and in this case, the name is name, which is some name. There you go. So much work to make the iterator. Unnamed is self unnamed into iterator. Names is self named order into iterator. Named is self named. There you go. All right, let's go next. Next this thing. So when I'm zipping, When I'm zipping, I have a question mark. The trade bound in tuple zip error. Okay, so what is this zip? We have the tuple zip error, which means this. And this is not an error, so we want to derive this error here, I guess. Derive debug error. Let's see, different amount of unnamed fields. 0 versus 1. Is that how you do it? Yeah, I guess that is. Let's see. 0 not present in other. Field this. And then field this is only present in other. Even though it's a lot of work, you love how iterators are implemented in Rust. The way I want to like have it is like it could be with less work. Like, you know how in some places I'm already like doing something like impl iterator, for example, or this, right? So the iterator over just the values is much easier to implement, right? I don't need to like construct my own type here. I can just return this thing, which is similar to returning the boxed iterator. I don't know, like, I mean, yeah, there are downsides to this approach though too. Yeah, I mean, it has advantages and disadvantages. Anyway, we have name, and so name is option string, and then this name is having this value in tuple A, this value in tuple B. We want to, so this is the type inference algorithm basically. When I see two tuples, it means that every field needs to be like the same thing, kind of. You know, so we say that result. So we're going to match name. Like the actual annoying stuff is over here. The actual annoying stuff is over here, where like this code that I'm writing here is literally just me. Like I want to map. Like let's say that I had a like an iterator. An iterator of type T, right? And I want to convert this into an iterator where item is U, right? But what I have is I don't have a function from T into U. What I actually have is a function from T into a result U and some error, right? So so I cannot just map an iterator, right? I need to do other things, and also like I'm not having an iterator, I'm having a concrete like data structure, the tuple in this case. So I cannot just use the existing map method. There maybe there is like something for iterators specifically, like, you know, how can you collect into a result vec, for example, to get to stop on the first error. Is there anything like that for normal iterators? Probably not in the STD, I would guess, but maybe in the iter tools. Like there is the there is a try collection nightly, by the way, which is nice, which is easier to find than the collection to a result, I guess. Try find, try fold, try for each. I reduce. But like, I mean, you cannot really like convert. an iterator in the iterator of inner values and throw a result, because that literally just doesn't work in Rust. You cannot even have this API. Yeah. Isn't the same problem with wanting to bubble errors from inside the closure past? Yes, exactly. So we are going to be able to have that because we will have like the effect systems. You can. There are examples like that in the Coca language if you are interested to see how it works there. But yeah. And similarly to the bubbling up errors from inside the closure, we also sometimes have the async stuff, right? So we want to bubble up the await too, not only the async. So because of that, I need to like construct and then like do these things manually here. Whatever, some name, then I result add named name fine. Name value. Over here we say result add unnamed value, where value is inferable make same A and B. Question mark. So the result is a tuple of types. Now that we have made everything this, we're going to have type tuple with the result. Okay, nice. That is working. We have the tuple types. This is pattern matching. I think pattern matching is like the only thing. Well, I mean, in order to pattern, like we also need to construct the values, right? Because in order to pattern match against the tuple, we need to have a value of a tuple. I have only made the type tuple. So now let's have a value. Value, one of the values is going to be tuple, which is a tuple of values, right? The equality, self tuple, self tuple A and self tuple B. A is equal to B. Where am I actually implementing the equality for tuple? I just implement ec here. I mean, technically this is the correct implementation if I just use the derived one. Yeah, this is fine. Yeah, this is fine. Okay. Let's go here, display. So in order to display a tuple, value tuple, tuple. Don't I just do tuple fmt f because this one implements display already, so I don't really need to do anything. This already is implemented. Type value. So the type of a tuple value is type tuple as ref map field type. There you go. This is the type of a tuple. What else? That is it. Now we need to do the pattern matching. Oh, there's also this display for type. Type tuple. I guess we literally do the same thing. We just try. We just do tuple fmtf. Okay, and this is the pattern matching. So if I have a pattern, which is a tuple, then first of all we need to assert that the value is a tuple, right? So match yeah, we're going to match value. I guess it must be a value tuple value. it's anything else, then this should be a panic, because like if we got to this place, it means that the type checking, I mean, yeah, this should not like get me an error, because this is already like doing the work after the type checking. Pattern matching, trying to pattern match tuple, but got value, something like this is what we want. This is our value. Pattern does not implement the display. Pattern does not implement the display. Let's have something here just so that the error message is nicer. Let tuple is tuple as ref map underscore, just this or something. So like so we don't go recursively into showing what every field is supposed to be. Tuple, this one I want it to be called pattern. I wish it was renaming this inside this too. Oh wait, hold on. It could maybe it does return. Yeah, there you go. It does rename. Nice. So now we have a value and we have a pattern, right? Both of these are tuples. This is a tuple of patterns. This is a tuple of values, right? So now what we need to do is I need to zip a value. Value. I want to zip value with the pattern. Maybe the other way around. Pattern ref map with values. And then I convert this into the iterator. Now I need to do a for. The names don't really matter here. But we do this pattern. So like this is field pattern and field value, right? We say something like match. We say field pattern match. We call this function recursively, basically match impl with the field pattern using the field value. We return this into the matches. We collect all the matches into this vec. There you go. That's all we need to do. Values, tuple value, not map but zip. Zip needs to be like expect something like pattern. Pattern is incorrect structure. Something. Okay, we no longer have any warnings. Nothing is going to work still, because there is still some missing parts. Let's just see what it is. Compiler 126. Compiler 126. This is so when I actually get the macro, right? I know that the macro exists now. We have successfully constructed a macro. All right, we have successfully constructed a macro. Maybe not really. Maybe it's not compiled in the inside, probably because I have not implemented the quote, right? But a macro is a macro which is like a function. So we're going to match macro. This must be a macro specifically. In any other cases, we are going to bail saying that macro is not a macro, right? But we were trying to use it as a macro. So over here, remove the R. Oh, I can remove the R. Okay, sure. Mismatch types, expected expression. Yeah. So we're like, we want to compile this into an expression. This macro is a function that's supposed to return an AST, which means that one of the other things that I'm missing is we are missing ASTs as values. That's what we're missing. One of the things that we need to have is an AST, right? Display value AST, FMT. ASTs don't implement the equality, so but I can implement that for them, I guess. Let's see, AST. Can I just derive? Probably not really. Implement ec for AST data ec impl data partial ec for AST data. So there you go. Let's see. If we have a simple and a simple, then we say that the token is equal to the other token and data is equal to the other data. If we have this, so this over here, if we are talking about the definitions, then I'm just going to use the arc pointer equality of the L definition and the R definition. Yes. And over here, syntax definition. Syntax definition is going to be the same. So equality of LDEF and RDEF. Okay, nice. And then we need to have the equality for the tokens. Right. Okay. Tokens. Token equality can just be derived. Partial ec hash. Sure. Missing arm here. The type is the type of the AST. So if I have a value which is an AST, and the type of this is the AST type, so I need to have that too. Type AST. And AST. And anything else is false. For the inference, we just need to this is types, right? Yeah, this is just types. So type AST, type AST is AST, but type AST and anything else is the failure. When I'm trying to display the type AST, and it is the AST. Okay, let's try again. Binding pipe right is not a macro because pipe right is Okay, I see the problem. So over here we set a let pipe, right? Which means if it's a let, it's a runtime value. So we need to have a const to make it a comp time value instead. Now we are crashed again. Compiler 128. 128. Over here. So over here, yeah. So we now have a macro. We now have a macro. This is a function, right? And I just need to call this function with my arguments. I just need to call this function with my arguments. I know that the values are these, right? This is the tuple of ASTs. Yes. Okay. Sure. So we're going to call this function. Let's take a look at where I'm calling the other functions. So when I'm evaluating function evaluate over here. So when I'm calling this should be me calling the function f, right? So self call function f using arguments, which is arg, right? Which argument has already been evaluated, right? Argument is value, f is also value. So this and this is a function, right? So we're calling a function with a value. There you go. That's what we want. This is going to be async and potentially fail. So something like this is what we want, and this should be extracted into there. Let's see, function call function. Call function. F is function and argument is a value. This returns result of a value, and this is also async. So in order to call a function, we make a new scope, we make sure that it's compiled and everything, and then we return the final value like that. Okay, now I can use this, call the macro similarly, right? Compiler. So this is a function, we just say self call, I guess kast call function, function f, since this is a function, with the argument. So the question is, what is operator question mark is incompatible types. Call function, this returns a value. Oh yeah, so like the value here. Okay. Let expanded. So like when we call a macro, we're calling this function which expands the macro into a new AST, right? So this function should return an AST. Match let expanded is match expanded. If it's a value AST, then it is the AST. Otherwise, we are going to panic, kind of. Let's do IRE fail macro did not expand to an ASD but to expanded, something like this. So this is the expanded value. Expanded, this must be an AST, and now I need to like compile this AST recursively basically after expanding the macro. So we do we do kast compile expanded await question mark like this. There you go. Now the question is, what is the argument to our macro? The argument is I'm going to have all these values. Hold on. So the argument is a tuple. I mean, it's not necessarily a tuple, right? Hold on. Is it a tuple? Always? I mean, yeah. Pretty much always is a tuple. Value tuple. Where its values as ref, map, ast clone. Apparently, because I need to own them here, right? Arguments to this enum. Oh, we expected a value. Yeah, so like every value is an AST here. That's what we want. So we'll give it a tuple of ASTs like this, which means that it's a value tuple. And over here we have inside value AST clone. Sure. Borrow of partially moved value macro. How is macro moved? Macro is just... Oh, I just need a name here, right? Macro name. Did not expand to the AST. Okay, sure. Let's try again. Recursion in async requires boxing. Because... Wait, in this function? Oh, in this function, yeah. Okay, sure. We just do boxed, and then we await like this, right? Ample futures output as a result cannot be sent in the threads safely. Something cannot be sent between the threads safely. I thought I had everything thread safe. Compile. Is it because I have the mutable reference here? No, I don't think so. Boxed local. Boxed local, though, is not what I want. Yeah, because, like... Because I need the things... unless I want to completely work within a single thread. I need to figure out what this is. So tcompile. Okay, so this is what they told me, right? Because if I use async functions in traits, then I lose the send stuff, right? So this warning that I have disabled, async function in traits, is not it. Which means that I need to instead do async trait. I need to add this as a crate after all. Cargo add async. Use async trait, async trait. And then it means that when I'm implementing, this also is async trait. And this is also async trait. Now it compiles. Okay, let's go again. We're going to panic in some other place now. Yeah, so now we say that we actually try to compile this macro, which is just this function, right? Inside this function, we're using the quote macro and then unquote macro too. This is for constructing new ASTs. That's what we need to have the quote and unquote macros. Now, So let's implement macro quote and macro unquote, I guess. Macro quote. Macro quote. Quote, I will for now only allow it in the expressions. But I want to do pattern matching against ASTs at some point too. We'll see though. Don't really need it right now. Time expression. Return OK, compiled expression. So we're going to have the AST expression now. We're going to have the AST expression. Something, something. Let's take a look at what we had before. Expression. You don't want to disrupt my productivity because I'm literally working towards 0.1, but there is a few improvements that can be made to the parser. Visual library, should you open them as issues? Yeah, sure. Open them as issues. If you know how to do them, you can like do them too. But I guess I don't know. It's like I'm working all over the place all the time, right? So we're going to have conflicts if someone else tries to work at the same code base. Maybe. Even although I don't really like touch the parser, it's extracted into its own crate, so technically not the like the parser touching that is fine, I guess. Struct ASD. So ASD have values and we have the data. Let's take a look at how it was implemented before. Do I just quote yeah, we just do it recursively. I mean, yeah, that makes sense. We just do it recursively. I mean, you can open an issue before you try, if you want to, and then close your own issue. So expression AST. AST expression. AST expression would be an AST expression which corresponds to a specific like definition. Right. Arc AST syntax definition, right? Similarly to how we had it before. And then we will have like the values, which is a tuple of expressions so that they can calculate recursively. Is that it? So in order to construct the AST, we need the definition, we need the values, and we need the data. Data is the span, and yeah. So yeah, so like in this case, the it's the tuple where every node in AST is another AST node, right? But when we have an expression, we every inner value is potentially another expression, which we will need to evaluate into an AST later. Yeah, there we go. Makes sense. Makes sense. Let's go back to somewhere. Expression AST. So this is going to be a to-do, right? The data is going to be the AST data. Clone, I guess, right? Well, I mean, what I want to have here, since this is the quote, yeah. Function quote. Function quote. AST should return result expression, which is an AST expression, right? So we're going to quote expression. But the expression is std syntax. If we take a look at the syntax, quote, yeah, we have like the expression field. So we say that let values and span is expect complex is get complex AST. And we say let expression is values into values tuple as ref into single named expression question mark sure, and then we so we have the expression AST, and I want to quote this expression. There you go. So in order to quote an AST, right, we there's like basically two things. Since I'm inside the quote, there is two things. We're going to match AST. It's either a simple thing or a syntax definition thing. This one does not matter. For simple things, for simple tokens, we are going to say that we just return a constant expression where value is value AST clone. Data is going to be AST data clone init, right? Like that. And then we have the complex node then, but complex node only if definition name is not equal to the so like the only reason we will stop is if we have the unquote. Unquote is built-in macro unquote, right? So as soon as we see a built-in macro unquote, we stop. So in this case, in any other case, well, I mean, if it's unquote, then the expression inside the unquote is going to just be, it's not going to be a constant. Yeah. So like this if is not a guard, I guess. This if is just inside this complex thing, I guess. So this is a to-do, but if it's not, then I'm going to return expression AST, right, where we have the definition cloned. We will have so the values is going to be there you go. Once again, the same thing. That move values. Let move result is tuple empty result. Data is data home init. So we'll go for name and field in values ref into iterator. We will have the field value. Value is so I'm going to continue quoting recursively the value, right? The question mark, and then I would say match name. If it's some name. How about we do this? Just do this. Result, add a name value. We need to have this method in a tuple for making this easier. So we have add named, add unnamed, but we will also have function add self where name is an optional string and value is t. So I'm going to match name. It's some name, then it is self add named name value. Otherwise, it is self add named value. Add named. Let's see. Like similarly over here that I have written before, result add a name value. Instead of this match. Macro quote. Okay. So and then over here, this to do. So if we have the unquote macro, let's see std syntax unquote. Unquote also just has the expression inside. So we just say that expression. Okay. Expression is values as ref into single named expression, right? And then I say that so this node is specifically just the this expression compiled into an expression, which means that this is async actually, right? Because compilation is async. Expression. Boom, kast. Root kast. This is async. All right. Kast compile. Kast compile expression. Await question mark, right? Like this. And then over here, this quote must be awaited. But we need some indirection. Right, so we need a boxed stuff. Can I check whether the hidden type satisfies auto traits? Fetching the hidden types of an opaque inside of the defining scope is not supported. You can try moving the opaque type and the item that actually registers a hidden type into a new submodule. Wait, what? I have never seen this error before. Can I check whether the hidden type of the opaque type satisfies auto traits? Because we want this to be send. I mean, yeah, makes sense. But it cannot figure out whether this is or not. I mean, sure. Sure. Let's have this as a function quote, which will return the box future. Box future. That's right. Let's say async move. So we box this instead. Consider introducing the named lifetime. Sure, let's introduce a named lifetime. Okay, so this now compiles. Let's go next. Evaluate. So when I want to evaluate the expression AST, should be pretty simple, right? It should be pretty simple. Values as a tuple of expressions, right? So we are going to do the same. Values is tuple empty. We go for name and field and value, I guess. In values, in values, into iter. We will return the value AST with the values in the end. Arguments to this enum variant is incorrect. Yeah, because this needs to be AST. AST complex is what we are constructing. Definition is the definition. Values. And the data, which is the span, is going to be the same as this expression, I guess, right? So data is data span. Data span needs to be cloned. Use of moved values. Values, AST values. Iterating over these values, which means that I need to do as ref here first. Okay, so we need to say that value is a self evaluate the value recursively, right? And then we AST values, we insert, we add name value. Expected tuple of ASTs, found tuples of this is values. Yeah, because value must be an AST, so we are going to say that value, we're going to match value. Let's say value is value dot expect AST question mark. Let's go there. Expect. Let's see here. There's an expect string. Expect AST gives us the AST, which means that this must be an AST. I expected type AST. Collect the bindings. If I have an expression, which is the AST expression that it does not introduce any new bindings, right? Expression AST. Okay. If I want to format this expression AST, we just write expression, no, AST expression. Expression AST. Expression AST. This is where I'm initializing. So if I have an expression AST, right? Definition doesn't, definition. Sure. Data is span. This is where I initialize the type inference. So the data would be expression data with span, and the type that I expect this to be is type AST. Also, in addition to the type of the AST expression to be AST, we also can assert that that the type of every value inside is AST, right? So for a value in a values dot iter dot values, I guess, right? We just say that value dot data type. I guess I'm going to clone it and then make same as type AST. A little bit weird, but okay to do. On WTF. Okay, looks like it compiles. Let's see if it works. There's no way it works yet, right? There is something still that I'm missing. All right. So in built-in macro quote expected expression, but got f and args. Field f was not expected while compiling the built-in macro quote. Over here, I'm trying to get in the expression. Wait, wait, where exactly? Wrap error with args to unquote. Is that the thing that is actually failing? Or is it the outer expression? Wrong arguments to unquote, yeah. Wait, what? Let's try running. Just run parse AST. Right? What I want to parse is this. Quote, unquote, f args, right? This is supposed to be a quote macro where expression is a call from the f, which is unquoted f, and argument is unquoted args. Yeah, I think I'm like this is the unquote. All right, give me a minute, guys. I have a call. Infinite Coder, hi. How are you doing? All right. What was I doing again? How long was I on a call? Ah. There's some issue with the macros. Do you make the issue, by the way, Nigel? Issues? There is no issues. The language is perfect. Still writing an issue? Okay. I mean, I understand. Writing is hard. You can see that by my commit messages, I guess. I mean, they're not that bad. They're not that bad, you know. I mean, some of them, something works. Some of them are bad. Some of them are not as bad as they could be. Still pretty bad. Writing is hard. So what was it? So the AST itself is parsed correctly. It's just when I'm trying to do this, we have wrong arguments to unquote. We expect the expression, but we got f and arg. All right, I need to have a call again. Wrong arguments to unquote. Expected expression, but got f and args. Because this thing, these values. Oh wait, hold on. This if is literally flipped. If the definition name is equal to the unquote, then I need to do the unquote. Otherwise, we need to do this other thing. There we go. It was literally flipped. Is it going to work? No way. Oh wait, no way. Look at this. It works. Look at this. This works. So we have a macro pipe right. This is a macro, which defines the behavior of this pipe operator, pipe to the right. So I'm trying to pipe to the right the hello into the native function print, right? So in order for the pipe to work, we need to have this hello as an AST, as an argument, have the native print as an AST here, and then we return this new AST, which is like, this is the built-in syntax for, I mean, not the built-in syntax, but like the behavior of this syntax is built in. How do we call a function? So yeah, there you go, the macros work again. Nice. Yeah, macros are easy. Templates are also going to be easy. This took me 2.5 hours though, but I think I mostly was like working on the tuples and other things, not on the macros themselves. Let's get rid of these warnings. Method expect expression is never used. Let's just allow that code here. Spawned is never read. Spawned is never read. Wait. A second. Spawned is true. I couldn't even find this reference. Oh, it's because okay, hold on. Kast spawned is not used. We have the same thing in the interpreter. Okay, yeah, that makes sense. Makes sense. We have two spawned fields in different places. I probably should like merge the interpreter into kast struct directly. Get sync and gate async are never used. Allow that code. Allow that code. Good enough. All right. So now the next thing is that this pipe macro should be defined not in the current like file that I'm trying to evaluate, but somewhere else in the standard library. It's like the standard syntax, right? So yeah, that would be nice to have. And then we will be able to basically finally run the hello world example, I guess. Std print, I guess no, not the std.print. std.print is a little bit, yeah. I mean, unless we do the yeah, if I implement the use std and make sure that that thing works. We'll see. Let me just commit this macros work. Yay. Yeah, I think doing the imports and being able to split into files makes sense at that point. All right. You know what? Actually, you know what? Actually, I'm gonna end the stream for today. The progress has been made. I need to do some other stuff. We have achieved a lot, Pigorly, yes. Let's go to Moss code. Does he ever stream with a microphone? I'm not sure. There's music, and he's working on some virtual machine. I'm not sure if it's a custom language or custom assembly, something like that. Something related to compilers, I think. Alright, but anyway, see you guys next time. Bye.